चलो, now we will see how to find a time period. Time period of any SHM. SHM I told you is a straight line to and fro वाला, not ऐसा वैसा नहीं है SHM. There is oscillatory motion. SHM is a straight line. I told you, remember always this, right? Spring and block, spring and block. So as oscillation वाला is nothing but SHM, right? Now इसका time period क्या है? कैसा, how to find? Not only this one, any SHM, how to find time period we have to know. Okay. So उसके लिए we have to know the time period of SHM method to understand time period of SHM. How to find any SHM, not only this one, any SHM, you can find certain methods there. Okay. So what is the method? How to find time period of a body under SHM? First, find equilibrium position. First आपको क्या करने का? Find equilibrium position. मतलब equilibrium position means net force is 0. And then write balance force equation. फर्स्ट स्टेप क्या है? आपको इक्विलिब्रियम पोजीशन फाइंड करने के बाद यू राइट द फोर्स इक्वेशन वी आर ट्राइंग टू फाइंड फर्स्ट. देन सेकंड स्टेप में क्या है? आफ्टर फाइंडिंग इक्विलिब्रियम पोजीशन एंड राइटिंग द फोर्स इक्वेशन, देन क्या है? डिस्प्लेस द ऑब्जेक्ट स्लाइटली x फ्रॉम द मीन पोजीशन. आफ्टर रीचिंग द मीन पोजीशन, आप फोर्स इक्वेशन लिखने के बाद उधर से डिस्प्लेस करो x डिस्टेंस, वांटेडली फोर्सबली योर एक्सटेंड x. ओके. And find new net force. At the time net force calculate करो, and mathematically we have to bring that force in the form of net force is equal to minus kx. ये फॉर्मेट में लेके आने का, net force equal to minus kx. Okay. And you know k is m omega square and omega is equal to under root k by m. And time period formula क्या है? 2 pi by omega. And 2 pi by omega is nothing but under root k by m, उल्टा क्या तो under root m by k. The time period equation will get. Here k क्या है? आपको जो k का equation जो आएगा ना, उससे comparison से k है. K can change. K can be 2k, k can be 3k, 4k, ऐसा कुछ भी हो सकता है. Suppose you will get like this net force का equation. Suppose you got minus root 3x आया. Then इधर what is the time period for this SHM कितना आएगा? 2 pi under root m by root 3. K can be anything. If k is k only, ये आएगा time period. नहीं तो दूसरा आएगा. Okay, always we have to follow this step to get the time period of any SHM. Time period of any SHM. And generally spring and mass का ये आएगा 2 pi under root m by k आएगा. एक derivation करेंगे, then formulas learn कर देंगे, हो जाएगा. कुछ नहीं.
Yes, sir.
Okay. So these steps follow करेंगे. So first equilibrium position find करके and write the equation. Okay. Example ले लेंगे. कैसा देखो. देखो spring mass system and I'm trying to find the time period of this oscillation of this SHM. मान लो initially the block is in our hand, in my hand में. Okay. इसका spring constant is k. Spring में पकड़ के रखा पहले. Okay, what will happen if I leave? What will happen? Tell me. If I leave, what will happen? Because of mg, the spring got elongated like this. I reach to here and m. Okay, this is the equilibrium position from here. मान लो this distance is x naught. Understand करो. मानो देखो x naught. मैं initially मैं पकड़ के रखा. What will happen when I leave? What will happen? Because of m mass, a ऐसा extend होके इधर आएगा. Now what he told? What to find the equilibrium position. Now this is the equilibrium position, right? Because इसके ऊपर force लगेगा. What is the force acting? क्या है formula? F equal to k x naught. Right, this is the equation. And नीचे कौन सा force है? mg. You know that when upper force is equal to downward force, then equilibrium position is equilibrium position. And at that time, he's telling to write the first force equation. What is the force equation? कितना आएगा? K x naught upward force equal to downward force. This is the force equation I wrote. So what is the first step we told? Find the equilibrium position. Net force is 0 and write the balance force equation. So always we wrote the balance force equation. That is this one we got balance force equation. Now इससे नीचे नहीं जाएगा. ऐसे लीव किया. Okay. Now what is the second step? See, our intention is to find the time period of this system. इस system का time period we are trying to find. Okay. चलो. Next step क्या बोला वो? Displace the object slightly x from the mean position. Now mean position से x distance out भी खींचो. मतलब this is a relaxed position, right? Now equilibrium position. Equilibrium position से still I will elongate. I will elongate x distance forcibly. This is x distance. This is x. And before it is x naught turn. And this is mg. Now ये balance नहीं है. इसमें हम लोग खींचा और भी मतलब the spring is having the force, right? ऐसा तो net force कितना होगा यार? Net force will be mg minus कितना होगा? ऊपर k times of x plus x naught. By force we will calculate always from the initial positions. Initial position कितना खींचा total distance is x plus x naught. Okay. Now mg minus kx minus kx naught. And you know what is kx naught? Is nothing but mg only. So kx naught के जगह में mg लगा रहा हूँ. mg minus kx minus mg. Minus mg plus mg cancel. So net force का equation is minus kx. Net force. मतलब he is telling to compare with the what is that? He is telling to compare with this net force. So now comparison में what is k? K is k only, right? In this case, k is k only. Some case they can give k is 2k, 3k, 5k. Now in this case, k is k only. Now when our k is k, what is the time period? Tell me. 2 pi under root
m by k.
So net force के ऊपर डिपेंड होगा. आप जो इक्वेशन इधर मत कंफ्यूज हो जाओ. आप जो इक्वेशन लिखने समय sometimes it can be 3k, 5k, 10k, 20k. That time period will change. That's the thing. So time period का spring and mass का कभी भी time period का 2 pi under root m by k is a very important. And इस chapter में 8 mark question will be coming IPM. 3 questions are that's it. 3 questions पढ़ो class, you'll get full marks in IPM. 8 marks आएगा. Okay. 2 pi under root m by k. Copy it. So it depends on mass, right? Mass पर depend हो रहा है ना, spring constant पर depend हो रहा है, right? चलो. Now suppose मान लो ठीक है, क्या हो गया? हाँ ठीक है, क्वेश्चन. The period of oscillation of mass m suspended from a spring negligible mass is t. एक स्प्रिंग है इनिशियली, उसका मास है m. इसका टाइम पीरियड is t. If along with it another mass m is also suspended, suppose I added another mass m and n. In that condition, what is the time period? T dash is summation. Calculate. In terms of t में चाहिए आंसर. Time period will change, right? Mass depend on ना. And spring is same, right? कितना टी बाय रूट टू टी
So root t, root 2 into t.
देखेंगे ऑलरेडी
So root 2t.
So t by root 2.
नो रूट टी आएगा बिकॉज टाइम पीरियड का स्प्रिंग एंड ब्लॉक का कभी भी टाइम पीरियड कितना होगा 2 पाई अंडर रूट m by k, राइट? So k is same, 2 pi is same, that means t is proportional to root m. That means t dash by t is equal to under root 2m by m. M cancel root 2t. So always it's spring and mass का. तो देखो some more cases we'll see. Suppose spring and block का तो मालूम है, ऐसा नहीं कि suppose ऐसा सीधा वाला नहीं है, not only hanging वाला, it can be this side also. Spring and mass. Tell me इसका टाइम पीरियड कितना होगा अगर मैं ऑसिलेट कराऊंगा स्ट्रेट लाइन मोशन? टाइम पीरियड विल बी सेम 2 pi under root m by k. It is not only vertical angle, spring and block का time period will be same 2 pi under root m by k. Now understand, suppose मान लो spring, mass and string तीनों connected है. I should be very careful. Spring, mass and string connected है. You should be very careful. देखेंगे, देखो कॉम्बिनेशन देखो हो गया ये वाला. चलो अब देखो, सपोज मान लो there is a pulley on the video मानो, there is a pulley, there is a spring attached to the bottom and there is a mass head. Okay, now इसका टाइम पीरियड चाहिए, इसका टाइम पीरियड चाहिए. So there is a spring, string and mass. उसका टाइम पीरियड विल चेंज उसका. ओके, सो कैसे है विल सी. इसका कभी भी फॉर्मूला क्या होगा इसका, इन व्हेनेवर स्ट्रिंग इज कनेक्टेड विद मास एंड स्प्रिंग इज कनेक्टेड, ये तीनों कॉम्बिनेशन में कभी भी टाइम पीरियड कैसे यूज करेंगे, 2 पाई अंडर रूट m by k dash, ये वाला यूज करेंगे ऑलवेज. टाइम पीरियड इज
What's k dash?
I will see what is k dash. फॉर्मूला देखो, k dash is equal to tension in mass by tension in spring whole square times k. K is spring constant. This is the formula it goes. Tension in mass by tension in spring into k. Okay, you tell me इसका देखो टेंशन T है, ये टेंशन T है, right? Now tell me k dash कितना है in this case में, k dash कितना है? टेंशन इन मास में टेंशन कितना था T by टेंशन स्प्रिंग में टेंशन कितना है T होल स्क्वायर टाइम्स K. So dt cancel. K dash in this case में it is becoming K. When it is K, substitute वाला फॉर्मूला में कितना होगा इसका, 2 pi under root m by k. Always use, very important, whenever there is a mass, string and spring, use this formula. That is 2 pi under root m by k dash.
So when there is what, sir? When there is? So when do I have to use this formula?
When there is a mass, string and spring. Okay, content, we have to use this formula. Okay, now करो, आप ही बोलो आंसर. There is a spring, there is a pulley, there is a string, and here mass and this. Now in this case में I want time per कितना है.
TS is tension of string or spring?
Spring. This is tension in mass, this is tension in spring. Now इसका बोलो. Pick up mass का tension T, a same tension T, and equilibrium this will be 2P. Now करो. K dash find करके time bits.
Sir, root 2t.
हाँ
Root 2t.
नो नो 2 पाई टर्म्स में बोलो 2 पाई अंडर रूट
Sir, I got
2 pi
T by
under root 2m by k.
नो रॉन्ग होल
Sir, I
स्क्वायर है ना
got
होल स्क्वायर क्या हाँ
T by 2.
नहीं नहीं इन टर्म्स ऑफ ये बोलो 2 पाई अंडर रूट वाला टर्म्स में
Oh, sir, pi under root m by k.
पाई अंडर रूट m by k ना रॉन्ग
Sir, 2 pi under root 4m by k.
हाँ इज आंसर 2 पाई अंडर रूट 4m by k देखो k डैश क्या है फॉर्मूला क्या है टेंशन इन मास मास में टेंशन कितना है t बाई टेंशन इन स्प्रिंग स्प्रिंग में टेंशन कितना है 2t होल स्क्वायर टाइम्स k तो dt कैंसिल k डैश कितना होगा k by 4 now टाइम पीरियड कितना है 2 पाई अंडर रूट m by k dash is k by 4 तो क्या होगा 2 पाई अंडर रूट 4m by k देखो ऑलवेज m by k नहीं आएगा 2 पाई अंडर रूट m by k नहीं आएगा आपको अंडरस्टैंड करो स्प्रिंग मास एंड स्ट्रिंग ऐसा है तो यूज दिस फॉर्मूला ऑलवेज ठीक है और क्वेश्चन करो आप ही करो टेंशन आप ही लगाने का कोई Now find the time period in terms of 2 pi under root में चाहिए
So won't the tensions be the same? Sir, I got 2 pi under root 2m by k.
2m by k ना no wrong
Sir, pi under root m by k.
pi under root m by k is correct देखो टेंशन t है तो ये बैलेंस है ना ये टेंशन t कब होगा ये हमारा
Oh,
t by
T by 2. Oh,
t by ना करो कितना
yeah, you get pi root m by k.
yes m by k okay चलो clear things you understand okay next we'll go for the combination of springs are easy series and parallel combination and formulas मालूम है ना series में क्या होगा parallel में फॉर्मूला क्या होगा we'll see देखो सीरीज कॉम्बिनेशन में आपको समझ में आने का इट इज एंड टू एंड यू कैन एबल टू आइडेंटिफाई इट एंड टू एंड वाला सीरीज एंड टू एंड वाला सीरीज है एंड टू एंड वाला सीरीज है ओके इसमें आवर इंटेंशन इज टू कैलकुलेट के इक्विवेलेंट इज उल्टा ऑफ द रेजिस्टेंस के इक्विवेलेंट इज उल्टा ऑफ द रेजिस्टेंस रेजिस्टेंस आपको मालूम है ना सीरीज एंड पैरेलल 10 क्लास में किया ना ऐसे इसमें पैरेलल का आएगा सो व्हाट इज द फार्मूला फॉर के इक्विवेलेंट टेल मी के इक्विवेलेंट इज 1 by k equivalent is equal to 1 by k1 plus 1 by k2 or k equivalent is simply k1 k2 by k1 plus k2 parallel ka combination will be coming in series in this way like resistance के साथ combine करो always ये series है tell me whether this is series or not this or not
So in place of k, you put k equivalent, right?
k equivalent to expect k equivalent is k1 k2 by k1 plus k2 2 pi not m by k equivalent so what are the combination you will get your substitute here see this is series or parallel one
So that's parallel.
why parallel
So I don't know, sir. I said all the same thing and it all is parallel.
प्रणव आप बोलो सीरीज है parallel
Series.
series कृषा series no actually ये series नहीं है ये parallel है
I forgot, sir. He told it was parallel, but I didn't tell the reason.
yeah I'll tell you parallel में है okay so very important आपको समझो this end to end connections only series है end to end connections of series okay so k equivalent आ गया ना k resistance का उल्टा k equivalent that's it simple हम लोग 10 क्लास पढ़ा ना रेजिस्टेंस का सीरीज का R1 plus R2 plus R3 पैरेलल का 1 by R equals 1 by R1 plus 1 by R2 इसे Okay. So now in parallel combination में देखो parallel combination में these are parallel. Normally हम लोग क्या है parallel तो आइडेंटिफाई कर सकते हैं parallel वाला इसे आइडेंटिफाई कर सकते हैं ना मतलब this end is connected to this end, this end is connected to this end. आपस में मिलना that is for parallel. Okay, इसमें very important when we should able to identify parallel में see I give an example this one. This is parallel combination. Why? How to identify means parallel में one end should be fixed. If one end is fixed and other end is connected with the mass, then we can say parallel. Very important. Understand करो वो लिख लो point में one end should be connected with the fixed end. Other end is connected with the mass. Similarly, other also same thing. देखो fixed end and mass, then they are parallel. मेरे वो लिख लो sentence. One end should be fixed and other end should be connected with a mass. Then also we can say they are parallel. This is fixed mass. देखो fixed mass. Then these two are parallel. These are fixed mass. They are parallel. ऐसा. So by seeing, we should not say this is series. आपको लगेगा, you know, concept समझ में आया तो ये पड़ेगा. अरे ये तो
for series also isn't it the same case?
Series में क्या होगा? Same to same. Mass नहीं है ना? ऐसा series. देखो end to end. I have 2 hands. Oh, that person has 2 hands. मैं मेरा friend connect करेगा. That is those are series. This is parallel. Now parallel में it is ulta of the series right. Formula क्या है? K equivalent is equal to K1 plus K2 use करना पड़ेगा. Resistance का उल्टा है ना? And time period will be 2 pi under root m by K equivalent. So whatever K equivalent, that one you have to use. This is the thing that is.
Sir, is the second diagram parallel or series?
This one, huh?
No, the one beside it.
This one, huh?
Yeah.
This one is parallel, right? Like one end is connected fixed end, other end is connected with mass. One is fixed end, other end is mass. They're parallel. Okay. Like हम लोग पढ़ा ना parallel में आपको ऐसा resistance. अब 12th class में आएगा.
All the examples are parallel, right?
These all examples are parallel.
Yeah.
Okay. 10th class में आती है. 12th class में current electricity chapter आएगा. मजा आएगा. Okay. आना छोटे वाला.
Yeah.
तो क्वेश्चंस करेंगे. फॉर्मूला याद है ना? K equivalent for parallel कितना है? टेल में. What is formula for parallel?
K1 plus K2.
For series में
K1 K2 by K1 plus K2.
for 2 और 3 है तो आपको 1 by K equivalent.
K3 by yeah.
चलो करो. Two similar springs, each of spring constant K1, are joined in series. The new spring constant and new time period will be changed by factor how much?
Sir, 1 by 2 and root 2.
Yeah, sir, same.
1 by 2 and root 2 is answer.
So 1 by 2 and root 2. Yeah.
Because I have the K equivalent and time period is right? So it's okay. Thank you. Two spring constant 2K are attached to the block M and fixed support. So this parallel series now.
This is parallel.
When the mass is displaced from the equilibrium position and either side it executes SHM, time period of always time period only. कहानी पूरा time period only.
So you get pi root m by k.
देखें, I don't know, but करो control don't bad answers.
Sir, 4 pi root m by k. So never mind, pi root m by
Pi
k.
root m by
Option
k.
C.
Yeah, see that. Yes. Next. Go. So mass m is held between two masses of less spring.
Frequency is omega, right?
Frequency is f. You know frequency is 1 by time period, right?
1 by oh yeah, 1 by okay. So the springs are connected parallel, right?
Well, you know, fixed and mass, fixed and mass.
So what's the point of alpha?
Alpha, oh, wanted to people generally have it, na? MG
Sir,
7
option 3.
So option 3.
Yes, correct. तो wanted see all देने से वो ये use करने का ऐसा नहीं है, they can give wanted. Okay. No combination. Time period of simplified directly given sometimes pi times of alpha m by phi k. The value of alpha is how much. तो मतलब टाइम पीरियड फाइंड करो उसका कंपैरिजन से अल्फा फाइंड लो.
So can I move a little bit? Sir, I have a doubt.
Yeah.
Sir, in the right part, the first both the K's are in parallel. Yeah. And then the combined and the bottom part are in series, right?
हाँ ये दोनों सीरीज है आने के बाद कंबाइन
Sir,
करके that one series
it becomes
बाद में
2.
आने के बाद they are
Yeah,
parallel.
sir, it's 12. Then it's 12.
Alpha
Sir,
ना
Yeah.
sir, even I got the same thing.
to use cut. Yeah. Cool. So parallel, series, and then parallel. K equivalent find करके again use कर टाइप 2 पॉइंट होता है m by k equivalent. You got from answer?
Yes, sir.
Yes. Sure. You know. Two springs constant k and 2k first are connected with the mass m. Okay. If the period of oscillation of the time period is 3 seconds, first period is 3 seconds given. What will be the period of oscillation? Figure B is root x seconds. The value of x is the time period given as 3 seconds. use this result in this somewhere to get your time period is how much. Put x again. X is how much.
So we have to just take ratio of the time, right?
Yes, ratio करता है.
Sir, root 2. X is equal to 2.
देखो.
So record root 2, yeah.
So x equal to 2.
So 2, yeah.
Yes, correct. Yeah. Right. So cutting of springs already Newton's laws of motion also we done cutting of springs. Yeah, there. A spring here is called spring constant k, and k is always in relation with length. Okay, so inversion. So when I cut into two equal parts, tell me what will be the this L/2 L/2. What will be the k value? Inverse relation means 2k 2k. Okay, inverse double करने half कहते हैं double हो जाएगा. Tell me if I equate it into three equal parts, tell me what will be the k value?
So k by 3.
K value 1. 3k 3k
3k.
ऐसा. K is inverse proportional to L always. So they will tell cut कर दिया and उसमें ये attach कर दिया उसका time period कितना है ऐसा पूछेगा वो लोग. So you have to know how what will be the k. K तो always cut किया तो k value will always change because length is changing. So that one you have to understand. Okay. Sure.
Yes, sir.
Time period of SHM of a spring constant is T. The spring is now cut into two equal halves and same masses is suspended vertically from one of the half by the new time period.
So, but initially you should connect in a parallel or series.
देखो एक टाइम पीरियड नहीं इनिशियल कुछ नहीं टाइम पीरियड टी बोल दिया नाउ स्प्रिंग कट इनटू टू हाफ्स में कट कर दिया था. ओके मतलब एक ही स्प्रिंग है वही पैरेलल सीरीज एक ही स्प्रिंग है.
Sir, T by root 2.
देखेंगे स्प्रिंग कांस्टेंट के टाइम पीरियड का टाइम पीरियड टी. नाउ इसको मैं दो हाफ कट कर दिया कट करके एक हाफ स्प्रिंग ओनली एंड अटैचिंग विद दिस मास. इसका टाइम पीरियड आस्किंग सेल बाय 2. हां
So 1 by root 2. I mean like t by root 2.
T by root 2.
Yeah, T by root 2.
So T by root 2. Good? Understood? Sure. No, simple pendulum. आपको 8 मार्क क्वेश्चन वाला यही आना है उसका डेरिवेशन आएगा आपको व्हेन यू स्टडीइंग वेव बुलेट और समथिंग दैट टाइम यू विल अंडरस्टैंड ऑसिलेशन का कंपल्सरी पढ़ना पड़ेगा ऑसिलेशन चैप्टर वेरी इजी चैप्टर है. ओके सो टाइम पे डेरिवेशन आएगा डेरिवेशन आप उसमें आईपी पढ़ेगा बट उसका फार्मूला आपको मालूम है. सिंपल पेंडुलम का फार्मूला क्या है टेल मी पेंडुलम क्लॉक का always
2 pi under root L by G.
L by G. Yes, 2 pi under L by G. That always when you're doing the derivation, the time period we are taking with a small oscillation only, not bigger oscillation, smaller oscillation. That's why some certain assumptions कर रहे हैं. Sin theta को theta ऐसा मान के we are do the derivation actually. तो उसका formula will be when the pendulum is the length of the initial length है ये ऐसा offset कर रहे तो zoom जाएगा ना. At that time what the time period will be 2 pi under L by G is the formula. Whenever the normal length of the pendulum ये lab में भी करें ना from childhood onwards you are studying 2 pi under L by G. ये लोग sometimes क्या करेंगे हमें oscillations में they'll combine gravitation also because G पर G is there, right? Gravitation में they'll combine G above the earth surface, G below the earth surface, at surface में क्या है, G will change. So based on that value or substitute and time period will change. So generally आपको कौन सा यूज करेगा फॉर्मूला में, बेटर टू लर्न दिस वन 2 by under root L by G effective. सारे टाइम्स में दे विल गिव सम केसेस में वो यूज करके G effective यूज करके देन सब्स्टिट्यूट विल गेट द टाइम पीरियड. ऑलवेज G एक ही नहीं है. ओके चलो ओके ऑलवेज
So the G effective can either be the G plus A or G minus A. That one.
I think it can be.
Okay.
Done? No. Consider G effective. Tell me, suppose एक lift है, it is going with acceleration A.
Sir, G plus A. G plus A.
G effective will be?
Sir, if the elevator is going up, then G plus A.
Okay. Downwards?
G minus A.
Okay, good. ये वाला समझना. We learned in the third law of motion also, right? mg and pseudo force के जगह में आपको ऊपर जाएगा ma, right? So G effective will be G minus A. लिफ्ट में देखा होगा ना आप, I told you weight will decrease while you going down. ऊपर में weight will increase as we go up. Okay? समझ में आया? चलो. The time period of oscillation pendulum of length L suspended from a roof of a vehicle which moves without friction down an inclined plane alpha. The options.
So the acceleration will be G sine alpha or cos alpha.
I don't know. G effective के लिए
Option 2.
ऑप्शन दिया.
2, sir.
ओके देखेंगे. No wrong.
So C.
Why C? Tell me.
So because gravity, like acceleration won't change, no, even if you're in inclined plane.
नहीं ऐसा नहीं है. आपको G effective के बारे में लर्न करना पड़ेगा. See what is saying? The period of oscillation of pendulum cloth of length L suspended from a roof of a vehicle which moves without friction down the inclined plane, moving down the inclined plane. The inclination alpha at the time, what is the इसका G effective? You tell me, then only will get time period आ जाएगा, right? Time period कितना होगा? G effective can tell me what are the G का क्या क्या things है? Tell me इधर G का we know the component state whenever inclined plane में what are the things here and here? Tell me. Here mg का we learn, right?
Cos and G sine.
हाँ, so G cos alpha, ये वाला G sin alpha. Okay, and therefore the acceleration कितना होगा? A equal to G sin alpha. Okay, but the person is in the moving frame. We are taking pseudo force. किस तरफ रहेगा? Pseudo force के लिए opposite direction के वो observe कर कितना ma, right? So कितना A G effective कितना होगा? G sin alpha, right? Now देखो net G effective will be how much? ये दोनों cancel हो जाएगा. Net G effective will be G cos alpha only. Net G effective will be G cos alpha. Therefore 2 pi under root G.
So how will there be a G sine alpha at the back?
Sin alpha नहीं, cos alpha नहीं, right?
Yeah.
Cos alpha is answer. Yeah, cut only. You told that one, right, Krishna? L by G. A you tell me B.
No, sir, I told B.
Yeah, this one. 2 pi under L by G cos alpha. This answer. So net G effective will be only G cos alpha when it's sliding down. Because it's getting cancelled,
Sir,
right?
why will there be a G sun alpha acting backwards?
Pseudo force.
Oh.
और याद है ना pseudo force always observer का opposite direction में आपको force लगाना पड़ेगा. Okay. Good. Next. Okay. The time period of simple pendulum inside a station lift is T. If the lift starts accelerating upwards with an acceleration G by 6, the new time period of the pendulum is.
So should we tell in terms of T or in terms of 2 pi?
Sir, C.
देखेंगे. The lift is going upwards with an acceleration. So G effective will be कितना है? Upwards में से increase करने का rate.
G effective will be G plus G plus.
So कितना आंसर which option I got?
Oh, that's now. So it will be 1 second. So it will be C.
Yes. Root 6 by 7 T. So G effective, even they can combine with the gravitation, or they can combine with the second year में electric field के साथ भी they will combine. Electric, because क्या होगा मालूम है? Whenever any electric field is there is a force acting. मतलब they will combine like this. M इसके ऊपर चार्ज है. सेकेंड ईयर में आएगा आपको. Okay. So electric field इस तरफ है. So इसके ऊपर force इसी डायरेक्शन में लगेगा. ऐसा based on the direction of electric field उसी डायरेक्शन में force लगेगा. From that we can find acceleration वगैरह, and G effective we can find and substitute करने का 2 pi under G ये वाला M by K. Okay. So pendulum में तो normally use करो 2 pi under L by G effective. Normal spring block है तो 2 pi under M by K use. Okay. These are all things about the simple pendulum. Next. Now physical pendulum. Physical pendulum. What is meaning of physical pendulum? Tell me. On the videos, what is meaning of physical pendulum? देखा है स्कूल में हो गया ना फिजिकल पेंडुलम. फिजिकल पेंडुलम.
Sir, I don't remember.
Okay. मानो प्रणव हो गया. There?
I don't know.
Okay. On the video I'll tell. देखो physical pendulum means nothing but any object other than the simple pendulum वगैरह. देखिए suppose I will put a mobile phone, I will attach with a pivoted point, I will attach and then swing करेंगे. This is a physical pendulum, not normal pendulum. Normal pendulum means एक string है, all these are normal pendulums. But physical pendulum means any object, any random object. I take a book, I will pivot it at one point and I will oscillate. That is not physical pendulum. उस टाइम में कौन सा टाइम पीरियड का फॉर्मूला यूज करने का? वी कांट यूज L by G वगैरह, राइट? उसके लिए क्या फॉर्मूला यूज करेंगे? So physical pendulum means any random object pivoted at this point, and I will make oscillation इधर उधर करके. So oscillation क्या क्या होगा? ये घूमता जाएगा, zoom करके जाएगा, and from pivoted at this point, right? And center of gravity मान लो here. When I oscillate the body, center of gravity moves here, right? And distance from the pivoted point and the center of gravity is L. distance from pivoted point and center of gravity is L. Okay, and angle मान लो theta is got. As a physical pendulum, it can be book, it can be anything. If I pivot at one point and start moving, I apply a force, I start moving this pivoted point. In that case में time period कितना है? You have to know learn करने का 2 pi under root, very important formula. It is I by mgl. Okay, where I, you know, right? I is what? Moment of
inertia.
देखो, I is the moment of inertia of body about pivot point. About pivot point. Pivoted point. I want moment of inertia of that point only, not about other point. That point. It can be rod, it can be sphere, anything also there. Okay, and L is the distance between the center of gravity and pivoted point. Distance between center of gravity and pivoted point. This is a physical pendulum का formula 2 pi under root I by mgl. And moment of inertia you know already. रॉड का कितना होगा कॉर्नर में मोमेंट ऑफ इनर्शिया कितना होगा
ml square by 12.
No, wrong. That is center में.
Oh, but corner ml square by 3.
Yes, correct. Good. Okay, copy it. 2 pi under root I by mgl. करो. Time period of a small oscillation of a uniform rod of length pivoted at one end. एक rod है pivoted one end. Now I want मैं swing करूँगा. Time period बोलो. 2 pi terms में बोलो. 2 pi under root कितना है? So formula I by mgl. Center of gravity is here, right?
So over here the ml square, like if it's ml square by 3 or something, and then the uniform length of the L, that's different or the same?
Which one? Capital or small letter? Small
like in the formula, it's ml square by 3, right?
ml square by 3, right? L is what? Total length of the body only.
Yeah, so is the length L the same thing or different?
No, same one.
Same one. So 2 pi under root 2L by 3G.
Yeah, correct. L is same, complete body का length. Here कितना है distance from pivoted point to center of gravity is L by 2. So वो use करेंगे. L के जगह में L by 2 use करेंगे अभी इसमें. कितना आंसर? सेम आंसर. 2 pi under root
2 pi root L by 3G.
Yeah.
2L by 3G, right?
Yeah.
Yes. ये वाला important है. About the diameter of the earth, you know already. Suppose you have to reach faster way में from one place to other place. Earth में क्या करेंगे? कल में?
So you'll go underneath.
अंडर में क्या होता है? क्या हो जाएगा? ये टनल है ना, इसको मैं एग्जैक्टली एक पाइपलाइन डालूंगा. एक पाइपलाइन डालूंगा पूरा अर्थ के अंदर में. प्रैक्टिकल लाइफ नॉट पॉसिबल बट अंडरस्टैंड. टनल डालने से क्या होगा? इफ आई लीव द पर्सन क्या होगा? ये जाएगा सेंटर ऑफ द अर्थ रीच होगा एंड ऐसे जाएगा. व्हेन ही विल रीच कितने टाइम में रीच होगा? मालूम है कितना टाइम रीच होगा?
84.5 minutes.
84.6 approximately minutes लगेगा. मतलब कितना फास्ट में जा सकते हैं? आई बिलीव. देन व्हाई वी आर नॉट डूइंग दिस वन क्यों इतना एरोप्लेन करके उधर से इधर 24 आवर्स एक पाइपलाइन डालो जूम बोल के बाय बोल के जाने का. बट क्या होगा मालूम है? फर्स्ट ऑफ ऑल इनसाइड में वेरी हॉट इज एयर. आप जाएगा बाद में एशेस से आएगा फर्स्ट ऑफ ऑल. ओके, दूसरा क्या है? सपोज द बॉडी केम क्रॉसेस हियर बिकॉज ऑफ ग्रेविटी. देखो ग्रेविटी इज ऑलवेज टुवर्ड द सेंटर ऑफ द अर्थ. आई यूज्ड टू टेल दैट न्यूटन लॉस ऑफ मोशन में द वेट इज ऑलवेज एक्टिंग टुवर्ड द सेंटर ऑफ द अर्थ बोल के. ऐसे ही आपको एक्ट होगा वेट जब जाएगा रीच होगा बिकॉज ऑफ इनर्शिया. ही विल गो बैक साइड. Again, when he's going backwards, again mg will be acting in the backward direction. That time क्या होगा? The person again will come back to the original position. So he will oscillate, start oscillating. He'll never reach to his relative place. He'll go on oscillating. अब फोन करेगा बोलते मम्मा पता नहीं, I'm go on oscillating, go here and there बोल के हो जाएगा. Okay. And the time taken to reach in this में formula क्या होगा मालूम है? Formula about the diameter of the earth में formula is 2 pi under root r e by g, radius of the earth upon g. This is the formula along the diameter, radius of the earth along the, and you will calculate, if I substitute the value and if you calculate, it is approximately 84.6 minutes. 84 minutes to बोल सकते हैं ऐसा. 84 point. Always whenever 2 pi under root r by g will come, even gravitation में भी आएगा. Gravitation में भी आएगा. Whenever 2 pi under root r by g comes, it is 84.6 minutes. It is not only diameter. It is not only diameter. Suppose any chord also. Not normally, suppose मान लो you're not only diameter. Suppose I put a tunnel like this also, or like this also. Okay. So इधर से इधर reach करने का, इधर से reach करने के लिए same time है. Time कितना है? 84.6. Okay. This is important. दो फॉर्मूला है. These are different types of SHM. That's it. Okay. एक फॉर्मूला है, हो जाएगा, चैप्टर हो जाएगा एकदम.
So you have to remember the value of 84.6.
84.6 always remember करो. 2.0. ये वाला क्या है? Time period means time taken to complete the oscillation, right? So that one. One time means कितना इधर से इधर तक कितना टाइम लगेगा? From here to here. This time क्या है? जाके आने के वाला टाइम, right?
84.6 by 2.
हाँ, ऐसे करना है. Okay. चलो एक और. These are JEE Mains questions only. Like given. Answer is simple. अब तक आ गया होगा वो आंसर.
So it will be 84.6 only now.
Yes. But there are few options there like this. 24 hours, 1 hour, 40 minutes, 1 hour, 24 minutes, 12 hours. So, approximately can tell how many.
Still 1 hour 24 minutes.
1 hour 24 minutes is answer. So minutes में नहीं दिया, वो लोग वैसे दिया ना 1 hour. Okay. And last one, one SHM is the last one. learn करना हो जाएगा. So suppose एक पानी में there is a block. Okay. A block है cylinder shape है. ये पानी में कितना डूबा है? H height में डूबा है. And पानी का density is rho. पानी का density is rho. And area of the cross section is pi r square. And इसका mass है m. इस cylinder का mass है m. Now क्या होगा? When if I given certain force and finally what will happen? It start oscillating. टिक 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 बोल के. वो भी SHM है ना? State in motion SHM. Then इसका time period कितना है बोले तो time period का फॉर्मूला है, लिखो 2 pi under root m by a rho g. A rho g. Rho is the density of the fluid in which you are inserting, and m is the mass of the thing. A is the area of cross section. Area of cross section which you are inserting at that area of cross section. And suppose in terms of height में, suppose sometimes they give in terms of height. That time क्या use करेंगे? 2 pi under root h by g is also important. h क्या है? जो पानी में डूबा ना, that one height. So these are the types of SHM. One more एक छोटा सा फॉर्मूला लिखेंगे, हो जाएगा उसका. Okay.
Yes, sir.
These are different types of SHM में. These are the one of the type, and one is earth tunnel का, and दूसरा है ये वाला. Oscillation of a liquid column. Suppose a liquid column, V shape का liquid column है. Theta 1 is what? From earth surface से surface straight line horizontal से वो pipe का कितना angle है अपन. And theta 2 is nothing but horizontal surface से pipe का angle है. Then इसका time period कितना बोलते हो? क्या करेंगे? 2 pi under root m by a rho g, which you know already, a rho g into, since angle is here, sin theta 1 plus sin theta 2. Sin theta 1 plus sin karo. This is the formula, and by this the chapter got successfully completed.